Hey guys, this is Taylor and today we'll be solving the problem split array by prime indices, which is 3618th problem. And this problem belongs to biweekly contest 161. This is medium problem. This was the first problem of the contest. Okay, so let's see what is given to us and how we will solving it. So problem is very straightforward. I think if you ever read the problem statement, that is very pretty easy to understand. So we have been given an array and we have to just determine. We have to collect all the numbers which belongs to non-prime index in one variable and all the numbers which belongs to prime index in separate variable, and we have to just take the sum of those two arrays and we have to take difference of it. So the first approach that we all have done must be, so the very simple approach is, let's quickly talk about that approach. So we must have written some function is prime, and inside that we pass an array and we just return whether the number is prime or not, is prime or not. So we in problem in actual when we will be writing the code, what we'll be doing, we'll be just iterating over all the indexes that will be taking the order of n time, and the next thing, this is prime function, which like if we optimally define this, so we can get a time complexity of square root of n from this is prime function. So I'm not getting in very detail of this simple question because I will be focusing more on this approach, which is just the optimal version of this normal version. Okay, so let's quickly see. So this is basically given to us, and what is our pseudocode look like? So I will quickly write it for uh, index. Let's say I from 0 to n minus 1 we will be going, and what will we do if is prime equal to I should write something like this, nums of I equal to true, then I need to add it in somewhere otherwise. So I can define sum 1 equal to 0, sum 2 equal to 0, otherwise I will be adding it in sum 2. So that is it. That's a pretty simple problem, and in the end of the day, what we can do, we can return the sums difference with absolute value. So sum one minus sum two. So it doesn't really matter whether you write sum two first or sum one or sum one sum two, because we are taking absolute value. So this is basically a approach that everyone must have done, and it's very simple approach. So this is basically order of n time. This is a square root of n. So our overall time complexity become n into square root of n. So this is we can achieve by this method, normal prime method, but we have some optimization here that we can reduce this square root of n time. Okay, so let's see how we can do that. So we have something like sieve of eratosthenes, whatever this is. So what this method tells us to do is, I will just briefly tell you here. I will create a separate video for this topic so that you guys can better understand this. So with this method, what we can achieve is we can declare a prime array, and our array size will look like whatever the constraint given to us. So let's say our constraints are 10 to the power 5, right? So this array size will be containing all ones. Okay, 1 1 1 1 1. How many times? 10 to the power 5 times. And this will be my size of array, and this array will be basically indicator of my prime, whether that number is prime or not. So if I have to check whether 1 is prime or not, I will go here on the first index and I will check, okay, first is prime or not. If I have to check 0 is prime or not, so I will go and check here whether this is prime or not. So this will help me. So there is something like how we can calculate this array, that I will be creating a separate video to understand better. And let's for now just consider that. we have something like this, some array like this, then how we will do that? So approach is very simple. Instead of this is prime, I will just call the prime array and my task will be done. So I will just check whether prime of nums of whether prime of I. So it should not be nums of I. It should be I here. Okay, that was a silly mistake I did. So if you have to write approach for this code, so I will just quickly write it. So for I to from 0 to n minus 1, I will check if prime, this time I'm using this array, not the function, prime of I equal to 1, then I can increment my sum 1 plus equal to 1, otherwise I will increment the second number. Sum 2 plus equal to nums of I. Nums of I. Okay. So at the end of the day, we can similarly return the absolute value of sum 1 minus sum 2. So how we can determine this primary, I will be definitely creating a video and I will be putting it in the description. If you don't know this sieve of eratosthenes method, so definitely go check it out, because in this question, this approach is submitted because the constraint is from 10, like 0 to 10 to the power 5. But let's say if we have constraints from 0 to the power 7 or 8, so this might not work. So we definitely have to shift to this approach, which is basically more optimal. So we should definitely try to learn something new. So okay, this is it for with this video. Let's try to quickly code this as well. So here is my prime function. Let's quickly code the first approach. So for I in range, okay, I'm putting outside the function length of nums. I will be defining my sum one equal to sum two equal to 0. I am defining my both sums. It is prime of I equal to 2, let's say. Then I need to increment sum one plus equal to nums of I. Otherwise, I want to increase the second number. In the end of the day, I have to write sum 1 minus sum 2. So I have written the is prime function in advance. Let's try to like quickly understand it. So one is I know it's basically non-prime number. If I'm having 2 or 3, I know one thing for sure that this is prime number. If number is not 2, not 3, then what is the case? Basically, if number is getting divisible by 3 or 2, then it means it is a false. It is not a prime number. Otherwise, I am starting loop from 4 and I'm going till square root of n. This plus 1 is basically including this square root of n. And I'm just checking if number is divisible by any of the previous numbers, then it will not be a prime number. Otherwise, it will be a prime number. So this is my simple function for the is prime function. And let's try to submit and see whether the code is working fine or not. I can write something like this also. That should be more correct. Okay, fine. So let's try to submit and see whether it's working or not. So it is working fine. Okay. So now let's quickly tell. I will just take the C wala thing from this code. So this is one method that we'll be discussing in detail in the next video, because this is some different concept which can be individually learned. So instead of this is prime, I can remove this is prime function now, and I can consider one thing that this sieve of prime will basically tell me whether my array, whether my number is prime or not. So I'm just going like this. So here what I have done, I have defined the max range as 10 to the power 5 plus 1. Why plus 1? Because this is indexes, right? So my index starts from 0 to 10 to the power 5. It's including, that's why I'm having plus 1 here. Okay. And I'm having zeroth index is always false and first is always false. And we will go in detail how we come up with this. So let's for now just focus on this. So sieve of prime, I'm checking whether if it is equal to true or false. Okay, I'm true or false setting. So it's true, then I can implement the sum, otherwise sum true. Okay, let's try to submit and see whether this code is working fine or not. Okay, let's try to submit it. Okay, it is working fine, and you can see the time difference, right? So previously it took like, so you can see here as well. Actually, this is not every time accurate, but for example, I think this time it's accurate. This time it took 54 milliseconds, but for my previous submission, it took 649 milliseconds. So the difference is actually correct, and we'll be discussing that in next video. I will putting that in description, so make sure to check it out. So thank you very much for watching this video, and we'll meet in the next one. Thank you.